We're kind of skipping over chapter 7 because you need to have this for lab 2. It's a really big component of lab 2. So we're going to talk about authentication, authorization, and accounting. It didn't hurt that, you know, I also had a crisis at my day job, like from 6 to 6:30 tonight, and I didn't get class started for like a half an hour. That happens at least once in the quarter to each class. So anyway, authentication, who you are, authorization, what you're allowed to do, in accounting, what did you do? All right. If you've taken 471, this is a big key piece of the CIS467 and understanding access controls. So the dependencies, you can authenticate without having to authorize anyone, and you can authenticate without turning on accounting. But if you are going to be authorized to do something within a system or be accounted for doing something in the system, you first have to be authenticated. Okay? So we're going to concentrate on authentication here in lab 2. And we're going to do that with Radius. Okay? Which is remote authentication dial-in user service. It's pretty old, but still very popular. For use with AAA servers and in a client-server-based environment. All right, it uses UDP as a transmission protocol for communicating, and it uses port 1812 and for authorization and authentication, and 1813 for accounting. Earlier deployments of Radius used 1645 and 1646, but we're not worried about older deployments. Okay. If you look at figure 8.2, page 273, this is how the Radius functions, and it basically leverages a shared secret key computed through an MD5 hash to produce a 16 octet value. Okay, that is XORed, and we'll get more into XORed when we get into cryptography. We basically said this states as does it match or does it not match for that given password, that pre-shared key. In comparison, TACACS Plus, our terminal access control system, which sounds kind of redundant, is a Cisco proprietary. Older TACACS was open source, but it uses a modular approach with AAA, where you use a network access server that is dedicated, and it uses TCP port 49 for communication. So the big difference between Radius and TACACS is one uses UDP, it's fire and forget. It basically sends its information in one direction. Where the other one is TCP, it's connection oriented. It uses it sets up a channel, okay, a three-way handshake, okay, where you can do windowing and session information and all this other good stuff. Now, this is good because of the benefits you get from TCP. Radius is good because of the way that it does its encryption. And here's why. TACACS uses a shared secret like Radius, but instead it uses an algorithm to calculate multiple MD5 hashes using rotating keys based on that single shared key. So it morphs that password. Okay? But in doing so, it can only do it with a limited basis. So the hash for each packet is only 16 bytes long. Okay, 16 bytes, 16 octets. Rotating key, this stays the same. This is harder to crack one time, this is easier to crack one time, but by the time you crack it, you have a limited amount of time before it changes again. Okay, so that's kind of the comparison between Radius and TACACS. They both have their benefits, they both have their detractions. They're both kind of used equally. TACACS, though, being Cisco proprietary, you've got to buy the software or hardware from Cisco to use it. It'd be very expensive. What I'm seeing more in the industry is people just stand up a Linux server that runs Radius or a Windows server that runs a Radius service, and they're done. Free of charge. No added cost. See that a lot nowadays. So Cisco is doing is they're taking their old ACS server and they're bundling it into a package called ISE, I-S-E. I think it stands for Independent Security Engine. But they're using that in conjunction with web filtering, mail filtering, this kind of security add-on appliance. So how do we turn AAA on? Well, we use the AAA new model global command. And then a combination of AAA authentication, AAA authorization, or AAA accounting commands with additional string values after them, basically saying how we're going to set stuff up. If you go through the configuration examples on 285 and 286, you will have a good insight of how to set up R1, R2, and R3 to communicate with your Radius server that we'll build next time. I know we said we're going to do it this time. We'll do it next time. I'm going to go through the router commands tonight. And here's why. You need to create a VM, either 2003 R2 or 2008, to stand up the Radius service in order to get that to work. Excuse me. Yeah, and yes, I have to go run another 2 to 3 miles tonight. I don't know how I'm doing this. But we're going to go through the router configurations this evening. So, you can load up or get a Windows 2003 or 2008 server ready. I'm also going to show you how to hook that up in GNS3. So, let's do that first. I have my Lab 2 running. It's the same one I had running from the other night. And one thing that I did do on R2, okay, and you have to do this, is I changed that IP address from .1 to .2. Now, I didn't add this in the notes. If you keep it, if you change it back to .1, I'm not going to take any points off. This is if you want to go through the steps and actually test your configuration, which I suggest you do. You need to change it to .2. Why is that? Well, when we set up VMware, and I have a when I set up this VM, I want to do a couple different things. One, I want to go to the settings of the VM itself. Click on settings. And make sure that it is on the custom VM net. Okay? Make sure it's on a host-only VM net. Okay? Secondly, if you're using VM Workstation, you have this handy-dandy little program called Virtual Network Editor. And what Virtual Network Editor will do, if you go to VMnet2, make sure it's host only, you need to make sure the subnet address is set up correctly. That matches your address that you want to have in GNS3. All right? But here's the downside. The virtual network adapter interface is going to default to .1 on that network. So if this is .1 and I make my router .1, what have I just created? A problem, yeah, but what's that problem called? An IP address conflict. You cannot have two devices on the same network with the same IP address. They fight for communication. All right? just being bad juju. All right, so that's why I changed the router to .2. Once that changes around and everything else, I can open up a, no. I can open up a command prompt, and I can just do some simple ping testing. Ping myself. I'm .128. How I find out that I'm .128 is through DHCP. I can just do an IP config /all. See that I'm .128. All right. I can ping my host adapter, my VM host adapter, which is .1, session ping. And I can also ping that router, which is .2. So I know I have connectivity. All right, good. Now, in doing so, if I go back to GNS3, and I basically loaded up all the configuration that I had done on Monday. All right. I can go to R3, for example, do my show IP route. I can see that I see that 192.168 network. And I can ping 192.168.50.2.1. Maybe not .1 because I have a firewall running on my system, but I should be able to hit .128. Oh, sorry. No problem. So why can't I ping .28? Ah, I know why I can't ping .128. My VM, when it gets its DHCP address, does not have a default gateway. Therefore, it's going to default to 1. It's going to default to 1. So what I can do is I can set up a static route in the server. And there's a couple different ways you can do this. The easiest way to do it is via command line. Okay, or actually the easiest way to do it is to go to my network connection properties. Reset this to a static IP address. I'll keep the same IP, but this time I'm going to change my default gateway to that router. You now see that I have that default gateway there. You can still ping me, so my IP stack is good. You can still ping my router, and I can still ping my VM host adapter. Now if I go back to R3, I can hit that router. Okay? Moral of the story, guys, is you really got to think from point A to point B, okay, and back again. So when you're doing a ping test, when you're testing connectivity, you're sending ICMP packets in one direction. They may get there. They may get there just fine. When I did that ping from R3, it got to the network. It got to the Ethernet interface of R2, the 192.168.50.2 address, and it came back. But when I tried to ping the server, it failed that first time. Okay? And it failed that first time because that server did not have a default gateway. So when you go through your testing, you may start looking, troubleshooting stuff and go, God, what's wrong with this ACL? What's wrong with, why can't I ping this device? Be careful because you may go down a rabbit hole. All right? And you may be going in the wrong direction. You have to think about everything, not just ACLs, not just security, but your routing, okay? To a lesser degree in this class, but a more obvious degree in networking, switching, VLANs, okay? Am I plugged into the right port with the right VLAN on it? Am I on the right network physically? Okay? A lot more goes into it than just, oh God, did I get past the ACL? I was having a conversation with one of our senior engineers and voice architects. He's studying for his CCIE voice lab. And this will be his, it takes it in a couple weeks, this will be his 4th time he's taken it. And he was telling me from experience, you know, one of the things that trips up all the voice guys is all the routing and switching they have to know when they walk into the lab. They could know a call manager backwards, forwards, and sideways. They could know a phone system, you know, very, very, very well. Same thing goes with traditional TDM voice techs and TDM voice engineers that have known digital PBXs and before that analog PBXs. All right? You come into the IP world, you come into the route switch world, if you don't know that foundation, you don't know that base, you're going to get lost real fast. That's what happened to him his first 2 labs. First thing he had to do was to set up his VLANs, set up 3 sites, set up the routers and switches. He wasn't very strong in routing and switching. It took him 5 hours. This is question 1 of an 8-hour lab. He knew that that was going to be a $1,500 lunch. That's what they call it, IE lab, a $1,500 lunch. Because if you don't pass it, at least you got lunch. Well, that lunch cost you $1,500. And trust me, it's not that great. So the second time he took it, he got that down to 2 hours. Now in his practice labs, he's got it down to 12 minutes. That's where you have to be at that level to get all that stuff right. So you can then concentrate on all of the voice stuff that is the real tricky part. So I hope he passes it. We need another CCI. So after I'm done with my PhD, I'm going to actually take the security. Actually, I'm going to take the security written exam here this summer. I'm actually kind of curious to see how well I do on it. All right, moving on. Let's look at AAA. So before I do that, turn it on real quick. One of the things I didn't talk about was how AAA functions. Okay, so I have up here on the board a diagram of a network. I have a couple routers, a firewall. These are switches. This represents an internal network. Typically, you'll have a radius server, or this could also be a TACAX server, that is going to hold information regarding the devices on your network. All right? As in what their IP address is and what the radius or TACAX key is going to be. In each of your devices, your routers, your switches, your firewall, you'll also input that radius information, and the IP address of the radius server, as well as that radius or TACAX key, pre-shared password. Okay? When somebody goes to log into a device, what you've learned up to this point is if you have a password and the login command on your VTY lines, if you're using Telnet, if you have SSH set up, you're going to get prompted for a password. And you give it that password, you log in. Take that a step forward, right? Get a little bit of a layer of security. You put a username and password in the router or switch or whatever. You put in login local under your VTY lines. Well, you not only have to know the password, you also now have to know the username and password. Well, here's the problem with that, and here's why we use AAA. If I just have a password there, the router doesn't care if I don't fail out on that password. I could just keep trying to type in a password and type in a password and type in a password and type in a password all the day long. It's not going to stop me. I can brute force that thing with a dictionary attack, basically. All right? I can script that and automate that. And it's just a matter of time and processing power before I crack that password. With the username and password, I just double that complexity. So now I have to guess the password, I have to put a username with that. It makes it a little bit harder, but yet not impossible. Because the router, the switch, the firewall is not going to care how many attempts I make. It's not going to block my IP address. It's not going to block where I'm coming from. What AAA does is you have a third factor of authentication, that radius key. Okay? So what I have to do is when I try to log into a router, that router is going to first take my username. It's then going to communicate to the radius server. The radius server is going to match its pre-shared key with the pre-shared key of this device. And say, okay, I can talk to you. It's then going to send that username to the radius server. And that radius server can do a couple different things. It will either A, look at its own database, because it can have its own database within it, or it can be pointed at another database, i.e. an Active Directory or LDAP database, to validate that username. If it comes back and says, oh, yep, that's a valid username, the radius server will then say, okay, what's the password you're trying to use? When it comes back and tries to use that password, it will then pass that password back to the Active Directory server. If it attempts, the login attempt is successful, it'll allow the user in. If it is unsuccessful, if you're using Microsoft Active Directory services, it will use the same group policy that if you were using if you were just trying to log into a network. So if you have 3 failed attempts, it will lock that user out permanently. Well, until somebody resets it. Okay? So it's kind of like a tripwire. If somebody tries to log in through these services and all of a sudden, hey, why is my account locked out? Oh, geez, I don't know why your account locked out. I can go into the logs of Active Directory and say, oh, you locked out, you failed 3 attempts. Did you forget your password? No, I didn't log in 3 times and fail. Never. I can then go, oh, where'd this come from? It came from the radius server. I now have an audit trail back to who tried to log in with that user's credentials, and then I can further track logs from here through AAA accounting or through syslog to find out where it came from. So in a sense, you've created just a small piece of a network forensic puzzle. Fun stuff, huh? It is. It's really fun stuff. Okay? I love going out on audits and explaining this to users and to IT managers because they're like, I didn't know you could do that. I'm like, well, you didn't go to Cal Poly because I didn't teach you. All right? So just an additional good practice to use. So let's set this up on a router real quick. So I've already set it up on R2, so I'm going to set this up on R3 since I now have connectivity to that device. So I want to go into configuration mode. Everybody see this okay? Let me raise it up a little bit. And the first command I want to do to turn the AAA engine on is that AAA new dash model command. All right, and then I want to use a AAA authentication command. Why is my tab key? All right. I want to tell what I want to authenticate, which is going to be logins. I have to give it a group name, which is going to be, I'm just going to call it Cisco. Tell it what it's going to be using for authentication, which is going to be Radius. And then I'm going to default to the local database in case I can't communicate with the Radius server for whatever reason. This is kind of a backup plan. So in case the Radius server hard drive fails or it dies for whatever reason, I don't lose connectivity to my infrastructure.
Is the login case sensitive?
Nope. This is case sensitive.
That's what I mean. So if I,
Oh yes, it's case sensitive.
You set it to all caps.
Yes, it is case sensitive. Okay. Now I want to set up my Radius server. So I'm going to do Radius-server, and then it's IP address. I'm sorry. Yeah, I have to preempt it with the host. Host, and the IP address, 192.168.50.128. And then the key, which is the pre-shared key. And I think I said everybody set that to Cisco. All right. And last but not least, I need to go into the VTY lines and change the login from login local or just plain login to login via AAA. So if I go into the VTY lines, it's login authentication and then that word, which is what the group word, which is Cisco. That's it. You're done. AAA is easy as that. About 5 commands. AAA new model, your authentication command. You set your Radius server, where your Radius server is, your Radius password. Then you go to your VTY lines and set the authentication.
You ever use authorization?
Authorization is another step. This is all you need to know for Lab 2.
Right.
So I can set authorization based on username and privilege level. It's like setting a group policy. It's nothing more than like setting a group policy within the AAA or Radius server. Okay? Now, this handy dandy cool stuff I put on our Blackboard page. I set up 2 links. The first one is basically to go over those commands that I just gave you that you need to have in all of the routers, 1, 2, and 3. Okay. Okay. You also need this command too. And what this command is going to do is identify the router by what interface. All right. So you typically want to do that. Use the interface that's closest to the Radius or TACAC server. So in the case of R3, I would do IP Radius source interface. Fast Ethernet 0, 0. So when it communicates to the Radius server, it's going to communicate with the source IP address of fast Ethernet 00. That's all it's saying. So there's a sixth command you have to do.
Wait, what does that do again?
So when I log into this server, or this router, and it communicates back to the Radius server, it's going to communicate using this interface's IP address, fast Ethernet 00, as the source IP address to identify itself to the Radius server. So in the Radius server, I need to have this router identified by the IP address of this interface. If I had it identified as this interface and it went that direction, it's going to have a source IP address of this interface and it's going to fail. So you have to understand, if I am sending information, what's my source IP address going to be? Very, very, very important. Okay? For example, when I send a ping from R3 to this server, what's my source IP address? It's 201.68.109.131. Why? Because that's the interface that is closest to this device. Now, I can change that up with an extended ping, some ICMP manipulation, and I can make it this interface if I wanted to. Or whatever IP address I wanted to make it, I can make a loopback address with whatever IP I wanted to give it and do it that way as well. But to answer your question, you have to make sure that you understand the direction that the packets are going in and what the source IP is going to be in order to do that command. Okay. Wow, I went through class fast tonight. All right. Huh? I tell you what, I will let you guys work on lab 2. If you have any questions, any comments, any concerns, if you want to get Windows 2003, this can be a 2003 server, 2008 server, just download whatever, and there's a WinRadius system on my website you can grab, or you can just implement Radius services through 2003 or 2008 and use that. That's the best way to do it. That other link that's on the website, if I go back here, that I posted today in the announcement, is this website, and it's setup of 2003 IAS server with Radius authentication for Cisco router logins. It basically walks you through what you have to do on the Radius server side. This is what I was going to go over on Monday. Okay? Because I have to build a server, because the server that I have right now is a 2003 server, but it is a standard edition. This comes only in Service Pack 2. And I don't want to upgrade this server because I need it for Lab 5, because I need it to be a very old server so I can pop it with Backtrack. So I got to build me yet another server. So I'll probably build a 2003 R2 server, or I'll build a 2008 server. Process between 2003 and 2008, it's almost identical.
If you had to pick one, would you just pick 2003?
I'd pick 2008, and I'll probably go over 2008 on Monday. All right. Any questions? Is this making your heads explode yet? This is some advanced security stuff, but you know what? This is what you encounter out there in the real world. Actually, a lot of times you'll go into a environment and they won't do this stuff. Why? Because it's too hard. But you'll know how to make it work. All right? You'll know what needs to be done. If you don't know how to make it work, or you don't remember, at least you can come back to some of these websites, some of the notes that you take, hopefully, and have a better understanding of the environment, of what best practices are and should be. I get to go audit a small little transit authority tomorrow, and I can't wait. It's the first audit I've done in about 3 years. I I kind of have some butterflies.